router ID was the case till the MTU. If the router ID is matching, that's it. Two-way neighborship will be formed. Okay, but in order to form the adjacency, two routers must have same MTU. The interface MTU of the router's interface should be the same on both the routers when to form the adjacency. And if the router ID are same on both routers, they cannot exchange the. Sorry, it is not the MTU. MTU are same on both routers, then they cannot exchange the topology database with each other, and routers will be stuck in ExStart state. Okay, why? Because in the ExStart state, they will be exchanging blank DBDs. In that database descriptors, they will be having this MTU carrying, and in the ExStart state, they will be exchanged, and both of them, they have to have their MTU same. If anything is mismatching, you are having 1500, I am having 1000, we will be stuck there in the ExStart state itself. And after a while, log will be generated reporting too many retransmissions. Clear? So you have to be very careful. Even the MTU must also be the same. Now I have formed the neighborship. MTU, I can give the value from 68 to 1500. Okay, on my interface here, my MTU is 1500 bytes. Here I will be changing it, but before this, adjacency, I'm debugging them, and then I will MTU, let me make it as 1000. Shed. Now, no shed. Can you see this? Neighbor 23.2 has larger interface MTU. Neighbor MTU has larger MTU. This process will be keep on going, and if in the meanwhile, if you see to show IP OSPF neighbors, you will be there in ExStart itself. It will not further move. It will not go. It will not furtherly move. ExStart, and these retransmissions will be happening, and after a while, it will be generating a log. More retransmission something. Clear? This is the thing. Let me and if you see here, ExStart 2 down, neighbor down, too many retransmissions. And why does this happen? Because their MTU is mismatching, and immediately it has cleaned up the database exchange and get him back to that old DRI. Clear? So this is what happens when you change the MTU. For this case, MTU must be matching on both the routers in order to exchange the database. That's it. Here, IP MTU, let me make it as 1500. Now if I give this no shut command, now you can see what actually process goes on. How does it go? Yeah. MD is 1500 matching. MD 1500 matching. Receive DBD. And if it is matching, they will be going to exchange done. And here ls request, ls, everything will be exchanged and state will be filled. Here. So let's take a 5 minutes break, not 10 minutes break, and then we'll see you later with authentication. Yeah. The next topic that we're going to discuss in the OSPF is authentication. Here, obviously, you know what is this authentication, right? As we have discussed in EIGRP, here the same purpose of using authentication. In order to advertise this network into OSPF, I have given the network command. I have to advertise it, so I have given router OSPF so and so. I have given network that matching this network. Let me suppose 10.0.0.0 with area 1. As I have to advertise this, I have given this network command. But actually, what does my OSPF router do? It will enable DND on this dynamic neighbor discovery, who sends all the unwanted hellos onto this interface. And by some means, here is an attacker who has replaced this PC with a router. And he kept on sending hellos, some millions of hellos per second. My router R1 is now being attacked with DOS attack, which is denial of service attack. Why? Because whatever the OSPF or EIGRP packets that our router receives, they are set with class of service 7 or 8. Sorry, 6 or 7. This is the highest level of service class. So whatever the data or traffic it is receiving, it keeps all them away and it just keeps on processing these hellos. Normal traffic is kept behind. There is a lag in the communication. Now the attacker is successful in attacking my router just using OSPF. In order to avoid such situations, we will enable authentication. And what does authentication do? Whenever authentication is enabled, my router keeps on checking the authentication field. If authentication is enabled, I will accept the packets if and only if it is carrying any authentication information. If not, no. If so, it is carrying authentication information, then I will check for the password. Key. What is the key value? If it's matching, okay. Not, I will not care. Here. So these are the major reasons why we implement authentication in routing protocols. Dynamic routing protocols. Clear? Yeah. And how do we enable OSPF authentication or authentication in OSPF? OSPF do supports authentication, and it supports majorly, we tell it as 3 types, but not only 2. Why? Because the first type, or we call it as type 0, type 1, type 2. This is by default enabled, and type 1, type 2 we have to configure it. And it supports both clear text authentication and also MD5 hash authentication. Whereas EHRP supports only MD5, no clear text. And authentication is of different types. If you want to configure authentication, there are 2 steps. One is, first you must enable authentication, then you have to choose what authentication type must be used. And according to the authentication type, you have to configure authentication key. And remember, authentication key can be configured only on interface basis. And if you want to enable OSPF authentication, you can do it at 2 levels. One is at the interface level with the command IP OSPF authentication, or else you can add message digest keyword in order to use MD5 authentication type. But this command is for interface level command. And if you think that there are multiple interfaces in a single area, and if you want to enable on them at a single time, then you can go to router configuration mode and you can give at area level. How? Enabling on all the interfaces of an area using area, to which area you want it, area ID, authentication, and message digest. If you are just giving authentication, it will be clear text. If you are giving message digest, MD5. In OSPF routing process, where will you give this command? In OSPF routing process, and this authentication command in interface level command. And remember, authentication key cannot be configured at area level, but it has to be configured individually on every interface. You can enable authentication for all the interfaces at area level, but in order to configure authentication key, you have to go to each and every interface. I mean, you don't have flexibility to configure key on this routing process. And as I told you, there are 3 types of authentication modes. No authentication, which is type 0. You have to remember this, which is what is type 0, what is type 1, and what is type 2. Type 0 means no authentication, is by default enabled. Type 1 means clear text authentication, and type 2 is MD5. And whenever you are doing debug, or if you are troubleshooting, your router will never tell no authentication or clear text authentication or MD5 authentication. It don't use these terms. It will use type 0, type 1 and type 2 terms in order to tell you what is the problem. Here. And yeah. And OSPF also supports multiple keys on same interface, but it doesn't support any keychain. If you remember in the EAGRP authentication, we have used keychain. Where in single keychain you can use multiple key IDs, and you can use time basis. At what time it should be key ID 1 should be used, at what time key ID 2 should be used. But in the OSPF you don't have such concept of keychain. Okay, it will never use keychain. And multiple keys can only be configured with MD5 authentication type. If you are using a plain text authentication type, you have to configure only single key. But if you are using MD5, you have flexibility to use multiple keys. And if you want to use multiple keys, then obviously you have no chance. You have to go to MD5 authentication type. Clear? And remember, MD5 is nothing. It's not a rocket science. Whatever the password you are typing or whatever the key value you are typing, it will be cryptographic, which is encrypted. Plain text, it will be in the plain text. Whatever the password you have given Cisco, it will be going as Cisco. Clear? And this is mainly useful when doing migration of keys, obviously. And keys cannot be configured per time basis. And how do you do it? Area ID authentication in order to enable authentication type 1. Area ID authentication message digest for type 2 authentication. But if you want to configure at interface level, OSPF configuration is, first you need to get into interface configuration mode. Then this is by default enabled. Authentication null is by default, it will be implemented. That means there is no authentication. And if you check any OSPF messages, they tell authentication null, means that there is no authentication. And if you want use IP OSPF authentication for type 1, which is clear text. And IP OSPF authentication message digest for type 2, which is MD5. And if you want to configure keys, IP OSPF authentication key, and then you need to mention the key value, which means the password, whatever you want to use. Whatever password you want to use, you can use that. Clear? And if you want to use multiple keys for MD5, IP OSPF message digest key, then you need to mention key number 1, 2, 3, so and so, and MD5 key value. What is the key value you want? This is for type 2. But remember, whatever the type you have configured here, if you are on these two interfaces, if you have enabled here type 1, and here if it is type 2, no neighborship. Same type, same key value. Clear? And how do you verify it? Show IP OSPF interface type and number. This will tell you what is the authentication mode type, and debug IP OSPF hello and debug IP OSPF adjacency. This will show you if any errors are there in authentication of OSPF. Clear? Here you have nothing. Now what will I do is I will enable authentication. Interface. Neighbors. Now neighborship is formed. Authentication. Message digest or null. First I'm using as is, where plain text authentication will be enabled. Here. And remember, and in between this, if you debug this, hello send, neighbor is down. Here. Why? Because here you have enabled authentication, but on the other side there is no authentication enabled. After authentication is enabled, here see simple password authentication enabled, which means that this is a plain text. Clear? Now neighborship has come up. Remember, though you have enabled authentication, if you are not giving any password, then authentication will not be work. Why? Because I told to authenticate. But what is the password I should use? It is a plain text, nothing. Right? Yeah. Authentication, key, and what is the password you want? Here, and on the other side, if you check, this neighborship will be down. (28), 27, 26, 24. It goes till 0, and then our neighborship will be down. Clear? Five, 4, boom. Down. Key. Cisco. Still no neighborship. It's completely case sensitive. Clear? And here instead I will give small letters. Immediately neighborship is formed. Loading to full. Neighborship is done. Here, this is a plain text authentication. Done? Yeah. C2 show IP OSPF authentication. Interface is 0 by 0. Now it is completely plain text. authentication message digest. When I do this, no key configured using default key ID value 0. And my neighbor, you see this no valid authentication send key is available for Ethernet interface 0 by 0 and our neighborship will be down. Here, for that reason I need to mention something. Here, and on the other end also message digest. Then my neighborship has come up. Here, you can see here neighborship has come up. Here, and these commands will be useful for you debug IP, OSPF follow and debug IP, OSPF adjacency. Let me make one thing. Before that, and now I will see this mismatched authentication type. We are using type 0, but the packet we received is using type 2. Here, this is the error message you will be receiving. And now see. Now neighborship is down. It is completely telling you what is the reason, mismatched authentication type. Here, and now it will be valid and immediately exchanges. And if you want to message digest key, then mention a key value here. In order to assign key, let me give it as 1 and then give my Cisco. Sorry, MD5, and then I have to give my password Cisco. What is the password I have given? Sorry, IP OSPF message digest key. What is a key number? What is a mode MD5 digest, and then what is a key value? You can see here mismatched authentication key, invalid cryptographic authentication. And when I go and if I here also message digest key value, let me give it as 2 and MD5 Cisco, and let us see if both are key IDs mismatching, whether do they form the neighborship or not. No. Now neighborship. If key ID, that means the key ID should also match. Let me give this as 1. No. Yes. So key ID should match, and immediately as soon as I have given this command, it has formed the neighborship. So key ID should also match along with the key value. Here, when you're using the message digest. Any doubts? And how do you check this? So IP OSPF interface is 0 by 0. What is the ingest key ID? 1. And here also the same thing as to EIGRP. Whenever I want to send authentication in hello, I will send hash of my youngest key. If I'm using 1, 2, and 3, I will be sending the key ID 1. Whatever I am receiving, first I will check for key ID 1. If this hash is matching, okay. If not, I will go for 2. If not, I will go for 3. But when I am sending, I will only send key ID 1. Clear? Neighbors. Detail. No. That's it. Here. So if you have any doubts, you can ask me. Yeah, regarding authentication, we have done the max we have. Clear? Yeah. This is regarding authentication. If you have any doubts, you can ask me. Let me remove all this. Yeah, right. So this is for authentication, right? And furtherly, we will be discussing. Okay, I'll show you the packets. How the packets can be there. Remember our OSPF in the IP header. How can our router identify which Protocol to does this belong to? With this protocol 89. And if you see this, these were sent with the source of interface IP and to the destination of 224.0.0.5 OSPF hello packets. And class 6. Anything more than this? No. And in here, actually, you are having 3 important fields. One is OSPF header. This OSPF header is added to each and every OSPF packet. And what does that information it carries? Version. What is the message type this header is carrying? Of course, it is hello. Length, and what is the router ID or source router ID? What is the area ID? Checksum, authentication. Can you see this number 1, which says that this is plain text authentication? And what is the password? Simple password, it is Cisco. And what do we have in hello? As I told you, in the hello, it will be matching area ID from the header itself. It should not match router ID from the router ID here itself. If there is any authentication, from where does that come to know? From the header itself. 3 fields are from here itself. Now remaining subnet mask and all this stuff, where do they come from? Network mask, hello timer, dead timer. Subnet mask and timers will be received in the OSPF hello packet. And other than that, these are some other stuff we don't need. Designated router, BDR. And what is a router priority? This is the stuff carried in the OSPF hello. And our packet and our router receives authentication information in the OSPF header itself, where here it is type 1, means that there is no MD5, it is a plain text and this is the password. For the same OSPF hello, everything is same. But if you go for authentication type is 2, which means MD5 digest. What is authentication key ID used? Key ID is 0. What is a cryptograph sequence number? And what is the hash of my password? Whatever the password I have given, it will never travel in plain text if you are using MD5. It will always be going in as an MD5 digest, and this is the digest. And whenever our router receives it, it will inspect whatever the keys it has. MD5 matching? No. MD5 matching? Yes. But whenever it is sending the hello, it will always find the digest of this particular youngest key ID, and that MD5 will be sent in the message. Clear? So where do you have this all? Router ID, area ID, authentication in the header, and network mask and intervals in the OSPF hello packet. Clear? So this is for authentication. Clear? Just give me 2 minutes. Yeah. So here in EAGRP we have seen topology table, right? Similarly in OSPF we have LSDB, link state database. This is the database where our OSPF router, whatever the information it has received in the form of LSS, it will be storing it in the LSD. In OSPF, each router stores data which is composed of individual link state advertisements in its link state database. Whatever the information in the form of LSS does it receive, individual link state advertisements, LSCS, whatever it receives, it will be storing them in the LSDB database. And every router in an OSPF area should have the same link state database information. And let us think this is a switch. Everyone is connected to that particular switch. And in here, let us think we are running some network. /24. These all are in single area. Now this means that, remember always, routers will never be in areas, but interfaces of routers will be in different areas. Clear? First thing. Second thing, now interface F0 by 0 of R1, R2, R3, R4 are in single area, right? Now these routers should have all the link state database for particular area 1 same on them. If R1 is having 3 links, R2, R3, R4, they should also have the same number of things or same number of LSAs. Why? Because whenever we are performing filtering or whenever we are performing summarization, at that point of time, these matters a lot. For that reason, every router interface in a single area should have all the database equal to each and every neighbor. And when the database is synchronized, each router individually runs SPF algorithm, like EAGRP used to run dual algorithm for finding the best path, who is the best path to find the loop-free path. Here OSPF runs SPF, shortest path first algorithm, and each router will, while running SPF algorithm, thinks himself as a root and builds the tree and finds the shortest path for the destination. What does this mean? This is R1 to R1. Two routers are connected. And let us think these all routers are in the same area. And he is also receiving the same. Here, what I'm trying to tell you here is our routers first they will receive LSAs. As soon as they form the neighborship, they build LSAs, and these LSAs are built in link state database. Once they are built, once LSDB is formed, it will be building the complete topology. Like LSAs are like what? Have you ever solved puzzles? No, or else you will be having games like this. You will be having pieces like this. Yeah. Now these pieces are LSAs. Our router runs SPF algorithm on it, means combining them, and on a whole network diagram is formed. But when you're solving this, you cannot solve as everything. You have to just pick one point, and for that point you will be matching everything and you will be adding the pieces, puzzles. Here the same thing our routers do here. Okay, then who is the center point that it should consider to match to build the map? It will be considering himself as a router. He is the root. Immediately will check, oh yes, on these interfaces what are the networks connected? These are the interfaces. On this network, who is the neighbor connected? Yes, I'm having 12 network, 21 network. Good. On 12 network, who is connected to me? On this interface, what are the LSS I am receiving? From R2. Yes, so R2 is my name. And what R2 is giving me? He is giving me about these networks. This means that to R2, these links are connected. And on R2 LSS, who are all his neighbors? R3 and R4. Now he has taken himself as a root and he has found half of the topology. And on the other one, 21, who is my neighbor? R4. And what R4 LSS is giving me? He is telling me about these networks. This means they are connected to him. And on this, he is having 5 and 6 connected to him. And this is done. On 6, who are all the neighbors? 8 and 9. For centerpiece, I have taken myself as a reference. I have first checked what are my interfaces, and these interfaces were all connected, and what are the networks connected to him. Like this, topology will be built. Clear? And once this topology is built, it will be in a single area. For suppose here this is obviously connected to some other area also. Now all these networks R4 knows. Why? Because his interface, this is also part of that particular area. But when he advertises that into area 1, instead of sending all the brief information as R1 received from all the routers in this area, he will not send all those information. He will only just tell, yes, 101 network, 102 network, 1.3 net, 104, 105 network. And he will tell 101, 2, 3, 4, 5. If you want to reach these networks, come to me. This. So that's it. Now, what are those links? How many neighbors are there connected behind you? Everything I will not know. And he will tell these are belong to another area too. As soon as I receive it, I will install them in my table and I will find if I want to go to them. I will not find whose network is this, who is connected to whom. I will not take any care. I just want whom should I reach to R6. Yeah, what is my cost to reach him? That's it. This is how topology is built in the OSPF. Right? And once the topology is built, then you will find the shortest path for the destination. Clear? And here, let us think it is connected like this. He knows on R2, this is the network and R3 is connected. And on R3, we are having some loopback 3.3.3.3. And R1 will check, yes, I am connected to R4, R4 is connected to R6, R6 is connected to R3. Oh, R3, I am able to receive from R6 and R2. Now, who is the best? I will check. What is this interface cost? 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 If I am going through 10, 10, 10, 30, but from R2, I am able to reach it only in 20. So I will go through R2. This is how first it receives the LSS, then it will build a database according to which network is formed. After the network is formed, it will find the shortest path first to that particular destination. And if all of a sudden this goes down, R2 will generate a type 1 LSA telling that interface is down. I will immediately break all the network and again I will rebuild it. And in the new rebuilt network, I will not have this network connected. This network, I will be removing this completely. I'll be having all the topology, but not this network. And now, if I want to reach this 3 network, what is the best network? Route only this thing, so I will follow this. Like this, SPF convergence will be going.